We have with us today a very unique speaker who doesn't only have a tech background, but also a very interesting personal background. In addition to being the CTO and Executive Vice President of Bazaarvoice, with 13 years of IT experience, including 4 of which at engineering leadership roles at Google, he's also a touring guitarist and has played on stages nationwide and has multiple studio albums recorded. So that's pretty unique.
They're all horrible, but we recorded them in the studio, so technically it counts.
In any case, horrible or not, please welcome Scott Bonneau.
Thank you guys for having me. I've also got R.C. Johnson here, who is the engineering head of our offices here in New York, just up the way off of Union Square. And yeah, just a very quick little bit about me. Actually, I grew up outside of Boston, went to school in upstate New York. I worked really hard to get an RPI loan. Outstanding. And my condolences for having to spend 4 years in Troy. It's a disaster. But I worked really hard to get rid of my Boston accent, but if it creeps back, I saw Good Will Hunting last night, and every once in a while it comes back, so apologies there. As was mentioned, I've been working in software industry since I graduated from college in 1999. Most recently, before joining Bazaarvoice, was at Google, actually here in New York City for a good chunk of time before relocating back down to Austin. And as was mentioned, in addition to doing software stuff, I also do play a lot of music and do video games. I've got a Legend of Zelda tattoo and an Assassin's Creed tattoo and stuff like that, so I'm officially insane. Let's introduce RC as well. RC.
Hi, wow, my mic is really loud, but okay. So I actually grew up in Missouri, and as bad as Troy may be, the town I went to college in is called Walla, which is a mispronunciation of Raleigh, because in Missouri they just steal names and then mispronounce them, which is bad. And it's a town of 10,000 people, 5,000 of which are students. It's a very, very tough town to go to college in. It's humid as hell. New York's got nothing on Missouri. So, but it's a good school. I had a lot of fun there. I did computer science, and then I actually stayed around for a master's in information science and technology. I've only had one job prior to working at Bazaarvoice, which has been awesome, both of them. But I've been at Bazaarvoice for 6 years now, both as an engineer and previously, and then now leading engineering here in New York. I've been here since December of 2011, and have built the engineering team here in New York from nothing to what it is today. So that's awesome.
So how many of you guys are familiar with what Bazaarvoice does? Maybe a quick primer. So Bazaarvoice basically started out, we're kind of a social commerce company, and so we were founded in 2005. We just celebrated our 8th anniversary. RC has been here for 6 years, so pretty much since the beginning, he's sort of one of our old timers. And you know, the basic thesis behind Bazaarvoice basically was, hey, Amazon is doing this really cool thing by putting user-generated content on their site and getting, capturing ratings and reviews, and that's a very helpful, sort of component to the retail experience. We should help other people do that too. And as hard as it is to imagine now, in 2005, Amazon was one of only 3 major internet retailers in the United States that actually had user-generated content on their site. It was 2005, and it's kind of hard to believe, but in 2005, like, nobody had ever heard of an iPhone, like, there was no such thing as Android, like, nobody knew who Mark Zuckerberg was, and Facebook was thrown out of a dorm room, so the world has kind of changed a lot since then. So one of the things that we're going to talk about in here, kind of the centerpiece of the talk, is sort of how Bazaarvoice has grown up, both sort of as the industry has evolved, but also in particular about how the technology has evolved. But sort of one of the centerpieces behind the value proposition of Bazaarvoice kind of comes down to this very stark statement, which is nobody reads ads. Which actually isn't entirely true. I work at Google. I'm fairly certain they make a little bit of money selling ads. It's a rumor anyway. However, there's definitely a mistrust factor when it comes to ads, right? But there is definitely a trust factor when it comes to sort of reading authentic opinions, whether they're by your friends or people that you respect or those types of things. And in much the same way as an advertisement, which is designed to get sort of an idea that's in somebody's head across, to further some goal, ratings and reviews really do the same thing. They kind of serve the same purpose, but they're kind of read in a very different way, have a very different set of meaning. So move on to the next slide here. So the basic proposition of Bazaarvoice kind of boils down to these these 3 bullets. The initial thesis behind Bazaarvoice was, let's help these online retailers really capture what people are already saying out in the marketplace, be able to facilitate that conversation, put it in some place, make it searchable, make it browsable, have it impact conversion, and have a better understanding of basically what people are saying out there. And there's kind of no more powerful tool than that, than what other people are saying about those products out in the marketplace. And that was kind of the original thesis. That was really the first several years of Bazaarvoice was basically taking that down. So some of our first clients were people like Golfsmith, headquartered down in Austin, but very early on we got some really big clients like Walmart and Best Buy. And I'm sure many of you guys probably never even heard us before you walked in the room, but I'm almost certain that you've used our services. And we've got a slide up here in a little bit that will talk about who some of our customers are. But if you have read product reviews or service reviews or anything on at Best Buy or Walmart or Travelocity or Orbitz or Nike or Sephora or Samsung or Sony, LG, you've been interacting with Bazaarvoice content. And the way that the social web has developed over the course of the last 8 years or so has created even more demand, even more value around this content. So as we evolve from simply the act of capturing and displaying reviews on an individual product page, the sort of value proposition of the company expanded a little bit. So the second bullet point here about connecting brands with point of purchase conversations. If you're a supplier at someplace like Home Depot or Lowe's, which are both customers of ours, let's say that you sell tools. A lot of times people have questions. They'll be like, hey, can I use this Dremel tool to do this thing that it wasn't designed to do or was designed to do? I don't really know. It's really hard for brands out there to say, oh yeah, like connect to that person and say, absolutely, you can do this. You can do it right out of the box. Or if you buy this $10 attachment, it becomes much easier. Or no, in fact, you don't want to do that with this tool. Instead, you should do it with this other tool. And so one of the things that Bazaarvoice does is we aggregate, for these brands that sell through a bunch of retailers in our customer base, the ability to kind of funnel all of these questions and answers, or a 1 or 2 star review generally is kind of a customer service kind of a problem. We're able to aggregate all these things across many channels that these folks sell through, give them one dashboard that says, hey, here are all your opportunities to interact with your client, push those things back out into the channel. And then lastly, enable retailers and brands to participate in shopper marketing or media. This is kind of a more recent evolution. You guys have probably heard about some of the stuff that Amazon has been doing. They just announced, I think about a year ago or so, sort of an internal pilot they had been doing about actually selling shopper media on their retail pages, and did something like $1 billion in revenue in the first year. And this is just becoming another way for retailers to monetize traffic to their site. This is particularly interesting as more and more commerce moves from the offline domain into online. Still about 90% of commerce is transacted offline, so offline is still really important. But as you can definitely see with some of the bigger retailers out there, whether it's Best Buy or Circuit City, who went out of business, or other folks, they're kind of suffering from the showrooming problem, right? You show up at Best Buy and you see something that you're going to buy, and then you go check the price on Amazon and decide, oh, it's cheaper there. You buy it on your phone at Amazon when you're standing in Best Buy, and then you walk out. And so these guys are looking for for more and more advantages to compete in that kind of an environment. We bring that kind of capacity to the table. So sort of at a 10,000 foot level, sort of how is it that we do this? We have basically a SaaS delivery mechanism for what it is that we do at Bazaarvoice, and it's a white label solution. So if you look here, sort of this is just plain old product detail pages at Office Depot and Best Buy. Anything you see in here that talks about average rating, I know the resolution here makes it a little bit difficult to see, but this is 4 stars is the average rating here. You'll see the review itself here, some content metadata, those types of things. We actually sit resident on this page. There's a little bit of JavaScript that we plug into the page, gets injected, and we actually render, a good chunk of the content is on these pages. For some of our bigger retailers, it can be as much as 40% or so of the physical real estate on the screen. Obviously it's a critical importance that the content here looks and feels like the rest of the site, so that the consumer's experience is very consistent, right? So as you can see in here, this is an example from Home Depot. We've got a different layout. The stars are different colors. The fonts and the styling are all very much in line, sort of with what with what the Home Depot says. And if you can flip back our seat to the previous page again, you see the same kind of a thing here, where we've got it just all this stuff flows very nicely and seamlessly into the site. In order to be able to go do this in a scalable way, we don't build a new instance of the software for every provider. So we've had to build a very configurable system that allows for styling and and display to fit the needs of our clients. And since some of our early clients were some of the bigger folks in the world, like Best Buy and Walmart, right, they put some pretty significant demands on the system. One cool side effect of the way that we do this implementation, however, though, is whenever these folks are getting traffic to their pages, their product detail pages, which is quite a lot of traffic, we get traffic too. So we actually get to see the behavior of people as they flow through the site. We get to extract some analytics, some very, very potent analytical data from that clickstream activity. And we'll talk about this a little bit in terms of how this impacts our technology, but also because of the fact that we have a network here where we serve Best Buy and also Walmart and Home Depot and Lowe's and Office Depot, those types of things. We have a lot of visibility into sort of what consumers are doing in the channel, and this is potentially very, very valuable information. So part of the work that we're doing right now is basically figuring out we talk about non-creepy ways to be able to utilize that data, in service of both the consumer as well as our customers. So the way that we do this is we do a very simple and straightforward integration via JavaScript. So I think we've got it down to the point now where we basically require one little JavaScript call that gives an ID for a div tag, and the rest of our code is basically injected from that point. So it's a very small footprint on the site. We serve literally everything that's required to drive the content on the site, including images, all the styling, the JavaScript itself, and again, importantly, we serve content every single time when these pages are viewed. Now, that's really cool from the amount of data that it gives us, but it's also really, it means we have some very significant problems of scale that we have to manage, right? So retailers measure conversion in terms of time on site. If you add 200 milliseconds, 300 milliseconds to the time it takes a page to load, they track these things and they see drop off in the funnel, right? So we're held to a very high standard as it pertains to being able to get our content on the site. And so that's actually really cool. We get some really cool challenges from an engineering standpoint in order to go do that. And this is just a sampling of the over 2,500 brands that we serve. So literally anytime you've been online and you've read a review or left a review about any one of these products or on any one of these retailer sites, without knowing you've been interacting with Bazaarvoice. Wish we could find a way to squeeze our name in there someplace, but not so much. So scale, as you can imagine, is something that's really important to us. So these are some stats that we do. We do about 100 million page views per day. We average about 800 million pieces of content displayed per day, and that can peak up over 1 billion. But I think one of the coolest things is we receive almost 100,000 new pieces of content every single day, which is just really, really cool. And so that means, I think RC and I were talking earlier, it wasn't all that long ago, that we signed our first client that had 1 million reviews. It was Hotels.com. Oh my God, they have 1 million reviews, one client. We get that every 10 days now across the base. And I think OpenTable right now is our biggest client by review volume, and I think they just pushed over 20 million reviews through the system. So that's we have a lot of really cool content in there. One of the really exciting things about this content that we have is it's very structured content, and it's tied directly to a particular product SKU. So we have a rating, we have the review text itself, which is largely unstructured but is parsable with NLP techniques. But there are also things like we capture information that the contributors will give us voluntarily to help with things like segmentation. So for example, if you left a review at Golfsmith on something that you bought, we might ask you a question like, how many times a week do you play? What's your handicap? Do you tend to play, mostly private courses or public courses, etc.? And this is really useful because this allows us to go segment the reviews, based on who the user is. One of our products called Bazaarvoice Intelligence, one of the reports in there is really interesting, is what we call for most polarized products. So these are products that have a whole bunch of 5-star reviews and a whole bunch of 1-star reviews, and that's really interesting, right? And one of the things that allows us to kind of get to the bottom of this to help our clients out is to be able to look at segmentation data. And we launched this product a couple of years ago at our social summit. The CIO of Golfsmith was there, and we were demonstrating this, and he said, "Well, go show me my #1 most polarized product." I said, "Okay." And it was a driver, and it was a customizable, kind of a configurable driver, and it had a whole bunch of 5-star reviews and a whole bunch of 1-star reviews. These really cool visualizations there. He wanted to drill down and see what the story was, and it turned out that like basically all the 5-star reviews were from folks who kind of self-identified as beginners. Like, this is great, this straightened out my slice, and it's really forgiving, and yada yada yada. And then all the 1-star reviews were from folks that kind of self-identified as stronger players, and they were like, well, it doesn't add any distance to my game, and it's really inconsistent, and these kinds of things, which is hugely valuable information. Right now, Golfsmith, like 2 clicks deep from landing at our site, has an actionable thing that they can go do with their data based on this information that we're collecting. If somebody hits that page and they've self-identified as an expert, we can say, hey, by the way, this might not be the product for you. Other folks that fit your profile actually kind of prefer these things instead. Or sort of conversely for beginners, say, hey, look, this is a really good driver feed, this slice you want to straighten out, those kinds of things. So we have this really, really unique, very significant data asset. I think we've got more than 150 million pieces of user-generated content that we've collected over the course of the last 8 years, and again, we're adding about 1 million every 10 or 12 days at the rate we go now. And then obviously, and sort of unsurprisingly, our biggest time of the year is the holiday season, right? So between sort of Black Friday and just after the New Year's, we typically double on a volume basis. And so this past Black Friday, we were serving more than 59,000 requests per second at the peak. We do about 2 billion pieces of content each day between Black Friday and Cyber Monday. And one of the things that I was actually the most blown away by, in fact, I made the team go back and rerun the numbers like 5 times, was when I saw that we were doing more than 400 million monthly unique users. To put that in perspective, Google is the biggest site in the world, and they do about 1 billion. So we're somewhere in the top 10, sort of in terms of networks, on the planet. And to put it in terms of Amazon is about 80 million unique users per month. So we have a pretty significant user base. All this adds up to, we need to have some really cool technologies to be able to keep up. So here's sort of a quick overview of some of the technologies we use throughout the stack. And one of the things we'll go into here in a little bit is kind of how we started and where we evolved to and the decisions we made and why. Our current infrastructure on the data side of the world is made up of a sort of a cornucopia of different solutions. We started out as a MySQL-based store. We were a simple 3-tiered architecture to begin with, and RC will go into some of the details on this in a little bit. We started leveraging Solr as read volume really started to pick up. When you get some of these customers like Best Buy and Home Depot, and for instance P&G, which is Procter & Gamble is a big sort of consumer packaged good, has dozens of brands that work with us. You start talking about traffic that starts to scale really, really quickly. And as you may imagine, the vast majority of the traffic that we do is read-based, right? A review gets written once and then it gets read, 800 million times a day, basically. So we had to do something to keep up with reads. MySQL just wasn't going to cut it, so we wound up leveraging Solr, which you guys are probably aware of, is an open source search technology that's built on top of Lucene. At one point in time, I think we had the biggest Solr installation in the world. I think there's somebody there's second. Source or second. I think
so there was an unofficial CIA one that wasn't allowed to be described.
Oh, okay, all right, cool. I'm not sure how we figured that one out, but we probably have to kill everybody in the room now that we've mentioned that. But so that's been a really cool technology for us. We've gotten that to scale up. We actually have hit some pretty significant scaling limits with Solr. We'll talk about those things in a little bit, which is why we've actually started leveraging ElasticSearch, which is a newer technology also built on top of Lucene, but it shares one sort of really important design or sort of performance characteristic that matters for us quite a bit, which is Solr has extremely fast performance for reads on static index, and substantially less good performance on index that's being updated frequently. We're updating and refreshing our content at no less than 15-minute intervals in production, and so we would run into really spiky performance with respect to Solr. It's really hard to manage at scale. You shove 150 million docs into even a sharded Solr instance, and it starts to have trouble. And particularly, as I mentioned before, right, our customers hold us to a very, very tight tolerance in terms of display traffic. ElasticSearch is a less mature technique, but it's designed specifically to work on an index that's frequently being updated. So we're rolling out a version of our display that's built on top of ElasticSearch. For our analytics, we originally settled on a columnar database called InfoBright to allow us to do a lot of sort of our significant analytics queries. We've actually kind of recently started replacing InfoBright with Vertica, which is a commercial solution. It's actually one of the few commercial pieces of software that we use in our stack. And then on sort of behavioral analysis side of the world, and our large volume event processing system is built on top of Hadoop. So we've got a Cloudera CDH4 cluster that's running in Amazon that consumes all of that content running through a system that we have called Cookie Monster, and drops all that stuff into a Hadoop cluster. We query out of it using Hive and Pig. On the application side of the world, we have, over the course of the last couple of years, largely rewritten our infrastructure to take us kind of from this monolithic Java application to a true services-oriented architecture to allow us to capture a lot of this value. We've traditionally been a very sort of Java-heavy shop, but we've added a lot of disparate technologies now that we have a true SOA environment. We have a lot more flexibility. We've got some Python applications that leverage Tornado. We've got some Nginx applications, and we've also become very, very heavy adopters of Node, particularly on the client side of the world. And then in terms of user interface technologies, our older system was kind of built on top of FreeMarker, which was an open source server-side Java-based client templating. But we have, like I said, we've really embraced over the course of the last probably 9 or 10 months a fully dynamic client-side environment that's based on primarily Node and Backbone. Some of our prettier UIs are built on top of Member.js and Angular. We have a couple of folks on our team who are really active in the community. This guy named Alex Sexton, who's been with us for quite some time, who is a committer on jQuery. So this is a survey of some of our technologies. So this slide is really meant to kind of talk to sort of more of our engineering philosophy. So I joined Bazaarvoice about 2.5 years ago, sort of in the run-up to the company going public. And at the time that I joined, and RC can attest to this, he's really kind of lived through the growth here. There were about 20 or so folks in engineering at the time that I joined. And when I joined the company, sort of my first job was go hire a bunch of engineers. I said, okay, cool, 10 or 15 people. Like, how about 120? So, okay, we're going to do that. We have to think about the world a little bit differently. So we instilled a philosophy, in the team of we want to be able to scale the organization, right? Scale means get rid of centralization. We need to do centralization is kind of anathema to scale. That means we need to have a whole bunch of sort of independently moving pieces or very loosely coupled moving pieces, that are bound sort of really only by their own ability to move as quickly as they need to go do. And we want to put together an environment that allows us to fail fast and iterate our way to success. We have a really engaged customer base. Some of them are very averse to change, but some of them are actually really, really positive on change. And there's some customers of ours like Travelocity who are literally like, sure, go crazy. Like, take 50% of the traffic on our homepage and just do experiments. We'd love to have you do that. So we're like, sweet, let's do that. So we've created an environment that basically allows us to go do that. We've moved from a really heavy kind of waterfall-based process to a Scrum variant in Agile, where I think our longest sprint cycle right now is 2 weeks. Many of them run at 1 week, and there's some folks that are even doing sort of continuous builds and deployment to production. And the point here is, the world is evolving around us really quickly. We want to be able to go capture new ideas and move as quickly as we can. The folks that we're out there that are that we're competing with are the Amazons of the world, and then some of the bigger folks like Google and Facebook that are snapping up a bunch of companies in our space and moving really fast. We need to be able to iterate as quickly as we possibly can, and that's driven both our organizational design as well as our technology, as we'll get into here. So for a very brief history lesson, Bazaarvoice basically started out as a very simple system. In fact, you can basically ignore like all of this. So it was really just an application server that was, Java, Tomcat, that used, Hibernate and Spring to talk to a MySQL instance, and, everything was hunky-dory. And we had one customer, and we had one chunk of data, and, the inbound request volume was really low, and this was perfectly fine. Over time, this became less and less true, and we needed to have more scale, particularly on the read side of the world. So we started out by creating a bunch of read-only slaves, which worked for a time, but then we hit a point where simply it didn't make sense to go to MySQL to construct a review every single time. We got to join, I think it's like 6 different tables together. It does something like 1,000 disk seats to construct a single review. It just doesn't make sense. It made much more sense to go shove that into a document, put it into a document-oriented data store that's designed to do constraint-based reads, and go from there. Solr did a really good job at that, so we became very proficient at deploying Solr. But over time, we started to hit even the limits of what Solr could provide. We got into a world where we were fine-tuning, particularly garbage collection parameters inside the VM, because you get like a GC spike that would go take, a query that would be 10 milliseconds, and suddenly it would take 15 seconds to go run, and some of the bigger customers, particularly around Black Friday, note that stuff and aren't very happy about it. So we got really good at doing that, but we kind of saw that what was coming, and we decided we weren't able to do that anymore. So we started moving in a new direction. Luckily, the whole industry kind of caught up with us, which was great. There were a whole bunch of really cool solutions that simply hadn't existed when we built the original version of the software. So you can see here, basically, we got some cracks in our foundation. First of all, for those of you guys that have worked with Solr, it's an amazing technology when you have your index built, it is really expensive to rebuild an index, particularly if you've got tens or hundreds of millions of pieces of content in there. In our, at that time, what was our 10-week release cycle, we would have to freeze the content, like, I think as many as 2 weeks in advance, so that we could go regenerate all the indexes if we had made any changes to the Solr schema. And if you made any changes to the schema, you needed to invalidate the entire index and restart again. So that was a pain in the butt. And if you found a bug, God forbid, in the schema, we're in trouble. So that was a problem. Much of the technology made it very difficult for us to sort of recover from sort of downtime and deployments. Multi-tenancy is obviously a key element to SaaS software, but what happens when you've got a MySQL database that's got Best Buy in it or OpenTable, and you've got 20 million reviews, and you've got maybe 1,000 other smaller customers in there that have a lot fewer, you start to have performance crossover that from the client's perspective really shouldn't be an impact, but there is. And then flat, we were just dropping a whole bunch of data on the floor. When MySQL and Solr were our primary data source, we weren't going to go shove 1 billion new events a day, into MySQL. Oh my God, it would have been a complete and utter disaster. You can't even shove 1 billion events a day into Vertica. So we were simply just literally leaving this stuff on the floor. And there was a ton of really, really valuable information in there. So we kind of realized, hey, we need to go make some changes if we're going to really be able to capture the value from here. And so about a year and some change ago, we decided that we were going to go revisit basically everything that we had done from a software standpoint over the preceding 6.5 years. And we thought to increase the level of difficulty, we'd do this right after we went public. And then we decided we would do it right after we acquired our major competitor too. So we like to crank up the degree of difficulty. But there were some basic sort of tenets to this re-envisioning of the platform, which RC is going to step in and talk to you about here in a minute. The first of which is this notion of chaos to the core. The idea here is, how many of you guys are familiar with the white papers and technical docs that Netflix has published about what it's done with Cassandra and AWS? So there's some really cool stuff that Netflix has been doing. One of the things that those guys sort of embrace as part of their core philosophy is chaos is going to happen, right? Machines are going to fail. Hardware is going to fail. Software is going to fail. So we're going to embrace that as a part of our design philosophy, and we're going to explicitly design the software to be really resilient. During my time at Google, they did very much the same thing, right? This was, revolutionary 15 years ago. You build everything on the notion of building everything on commodity hardware and building the software to be fault tolerant was very different, right? You had people who were building these big iron machines that you would go buy and would cost $1 million. It's still ultimately a single point of failure and still ultimately a vertical scaling problem. So we've decided to embrace this fully. We've moved almost all of our operations from a hosted colo with Rackspace, over into Amazon, and we built infrastructure that allows us to basically practice this chaos for real. We took some of the notions that Netflix created around chaos monkeys, right? Literally go in there and start shutting services down randomly, conformity, things that will go in and start shutting systems down if they don't, obey sort of good hygiene from a metadata standpoint, et cetera. We built those same things. Our stock symbol is BV, Bazaarvoice, so instead of monkeys, we have beavers. So we have chaos beavers and conformity beavers that are running throughout Amazon, causing all kinds of craziness. But the idea here is to just embrace the fact that at our scale, stuff's going to break, right? It's going to break. So let's make sure that the software fails, fails gracefully. We're going to store everything. So in the past, we said really, well, the review content is really what matters. Now we're saying everything matters. The behavior data matters. It matters a lot. In some cases, it matters more than the review content. Understanding what people are doing and why, matters a lot. One particularly interesting element here around store everything and why behavior data matters is depending on what sort of industry you're in or what domain you're capturing content in, the half-life of the value of that piece of content can vary really radically, right? If you're writing a review about a car or a television, it might have 6 months or a year or something like that of utility, right? If you're writing a review about a concert or a movie, it might have 2 days worth of value. It might be completely useless after 2 days. And so, we have to be able to capture that and give that information back to people who want to go use it, both consumers who are going to make a decision about, where to spend their money and time, but also the people who are generating these products and services in a way that makes sense. In order to be able to do that, we need to have a really holistic picture of what's going on. So it has become kind of a cardinal sin to lose any piece of information that the system throws off, either something we capture explicitly like review content or behavior data that we capture passively. multi-master and multi-data center, one of the challenges that we have moving forward now is we're a global company, right? And things like latency matter a ton, right? They matter a lot. We provide some layers and tiers. We leverage Akamai very heavily. We have a caching layer. But at the end of the day, we need to be able to provide very fast access to content sort of basically wherever we are. And we need to be able to survive in the event that there's a failure at any one of our data centers. And you guys are probably aware there were at least 2 significant Amazon AWS failures in the last 18 months. And we had a situation, I think, in Rackspace in Dallas where there was like construction near the site, and like a backhoe just literally took out the main fiber channel out of Rackspace, and it was like off the map for some period of time. That doesn't work. We can't work like that. So we need to be able to survive in this kind of environment. And then really importantly, we need to be able to get access to that data in whatever form it is we need, sort of at any time. One of the key elements, to our design, one of the things that happened over time is while like 99-something% of our traffic is read traffic and it needs to be really, really low latency, that's not the only use case that we have. We also do a lot of analytics. We do a lot of data mining. We do a lot of machine learning. And the requirements for the indexing technology that you're using varies really wildly based on what it is you're trying to go do. So I'm going to go shove all of these information. I'm going to go denormalize it heavily, put it into a document, shove it into ElasticSearch or Solr, if I'm going to go then read it 1 billion times in the next month. But if I want to go do analytics, say across an entire industry, like I'm going to go look at the entire online travel industry and say, hey, what is the average rating for hotels in the Caribbean across Travelocity and Expedia and Orbitz and Hotels.com, etc. That's a very different kind of a proposition. It's a very different kind of way of indexing the data and accessing the data that you need to be able to go do. And sort of one of the flaws in our initial implementation was we basically tried to use MySQL for everything. And just there is no one data store that works for everybody. So one of the tenets that we've got now is basically we're not going to try to build a single data store that stores everything. We're going to build a system that allows us to have a very nice horizontally scalable canonical master. It's based on top of Cassandra, and RC will talk about that here shortly. But then we want to be able to create secondary indices that serve whatever purpose it is that we have. Display happens to be one of those, but really, really heavy analytics queries are another thing that we want to go through with this one. And I think with that, I'm going to turn it over to RC to go into some of the details.
Awesome. Thanks, Scott. So if you think back to the cultural aspects of agility and of speed, and then think about the goals for this re-indexing, this rebuild project, this is the infrastructure that we came up with. There are probably 1 million infrastructures that could be built to solve this problem, but this at a high level is our solution, and we like it a lot. So ultimately, Scott alluded to it as the system of record. We call it that a lot, and I'm going to try not to slip and call it that. I'm going to try and call it EMO for the duration of the presentation, but if I slip and say system of record, what I'm referring to is EMO. So EMO is a Cassandra-based system. It's a set of different clusters of Cassandra that allow us to store all of the user-generated content, all of the product information in one place. It's meant to be obviously a collection of different clusters of that information, but then kind of all wrapped in a facade so that ultimately we can tailor the storage of that as we need to fit the needs of storing it, but also so that it's extremely accessible to all the teams. It's really straightforward. Oh, I need a product. I'm going to go to EMO. Oh, I need a review. I'm going to go to EMO. EMO is the emotions data. So we got into the habit, I guess about 2 years ago, of code naming every project, and so they all have pithy, fun names. And so this one was EMO, which was great because everybody thought, oh, we're tying that into the music. And I was like, no, we're just storing emotions. We're storing sentiment. Right? We're storing a rating, we're storing a review, that's a feeling. And so that's the emotions database. So everything is written and stored into EMO, and I'm going to go into more detail on each of these. I'm just going to give you the high level of the 3 different pieces, and then we can begin to flesh that out and see how those all play together. So everything that gets written to EMO fires an event on our data bus. A data bus here, I actually equated a lot to an enterprise service bus. I came from a much larger organization prior to this, and in a lot of ways I was grilling one of our strongest data engineers, the designer of the Cassandra-based system, and saying, why didn't we just use an enterprise service bus? Why didn't we just use Mule? Why didn't we just use an existing technology? Don't even pay for it. Use one of the open source ones. And he's a big proponent of open source, both the committer and the contributor, but also of using open source technology. We've always had a philosophy that as much as possible we're going to use open source technology because we can save on those licenses and pay for things for engineers to do, or good IDEs for our engineers to use. And so I'm on the phone with him the other day, I'm grilling him, and I'm just like, I don't get it. And the thing that he pointed out to me is that Mule is like a whole class of technologies that have been built, in that it was built really before the cloud existed. And there's really a seminal event that when Amazon dropped AWS, and AWS had SLAs, and AWS became the place you ran your application, software was built different after that. Everybody talks about the difference of when the internet came along, and that there was a huge change in software, and I don't disagree with that. And I'm not even going to compare the two events, but fundamentally, the fact that we have the cloud, the fact that we can deploy software out there, the fact that software runs out there, I don't have to own a server sitting in Dallas waiting for a truck to drive through a backhoe or take out an AC unit or take out power or any number of things is a very, very different proposition. And so we wrote a data bus. It's actually built on Cassandra as well, specifically to support multiple data centers, keeping a message queuing system in sync over time, and to have that be a persistent message queue. And so that's ultimately what it came down to, was that we need something that was at cloud scale. Like, you remember the goal that Scott laid out, that everything needed to embrace chaos to the core, right? With chaos at the core, I can't just have a single Mule server sitting out there. It's going to go away. Something's going to happen to it. So either I'm going to have to write all the protectionary code to handle multiple of these instances running and make sure that they fail over gracefully, or I'm going to adopt something like Cassandra that understands that I'm going to be running on a whole cluster of servers, that I'm going to have multiple masters, that I'm going to have multiple data centers. And some of that's going to disappear every couple hours, and that's okay. And so we built our own system of message queuing that gave us that persistent message queue. And the reason for that being so critical is that the last piece is the Polloi instance. I forget, it's a Greek reference for
It means for the masses. So this is the display index for everybody. It's designed to, yeah.
Which plays perfectly, of course. So it's ElasticSearch based. What Polloi allows us to do, and there's some really, really interesting stuff in Polloi, some of which I can get to today, and some of which I would love to sit and explain over coffee, but it didn't fit this presentation, but it's really some amazing stuff. It gives each team the ability to have their own customized index in an extremely lightweight fashion. So, for example, there are teams that are running our display traffic, and they're servicing reviews out as part of our core platform, and they have one traffic pattern. My teams here in New York are building applications that do aggregation across the network. So they actually look at Home Depot, Lowe's, Best Buy, Walmart Canada, et cetera, all the way across, and then show an individual brand like Vizio or LG or Canon, hey, here's your summary across our entire expansive network. Here's what's going on your site. Here's an opportunity for you to get engaged. We need a very different index than the team back in Austin. And so because of that, Polloi lets us do that. It's actually mostly built on Elasticsearch. I'm actually going to get into the internal details. There's actually a bit of Cassandra mixed in here too. There's some really interesting stuff. But basically what it does is it watches for each of those data bus events. It is subscribed as a listener, and it guarantees that it will get every single event, every single update will be processed by it and written to your search index. And then it's also got a rules engine. It's got some really neat stuff mixed into that rules engine that really dramatically simplifies managing your index, describing what content you want. And then there's a whole operational side that unfortunately, just due to the audience and due to time constraints, I didn't want to put into this presentation, but there's really some neat stuff that I'll hint at. So if you take a look at emo, we talked about what we were looking for, and one of our key goals was that it would be completely fault tolerant. And so with Cassandra, the attributes of Cassandra, and thus the attributes of emo, are that we've got this fault tolerance. We can deal with a single server disappearing. We can deal with an entire data center disappearing for some period of time. We've got horizontal scale on both the reads and the writes. It deals with multiple masters. Oh, yep. Let me try and stay out of the way. I talked about the multi-master just giving us a lot of scale, giving us the flexibility to linearly scale as we need to add more masters or as we need to add more read servers to the cluster. And it inherently understood the concept of being in multiple data centers. In fact, there may be temporary partitions between those data centers, backhoes and trucks and all kinds of hurricanes taking off US East if it happens. So emo was built around those attributes, and Cassandra fit those really well. So we considered MySQL. We gave consideration to a number of different technologies. MySQL being something we had built our kind of our bread and butter on, it definitely deserved our consideration. But MySQL had a couple of things. One, MySQL, to make it fault tolerant, to have it be truly flexible, for a server to go down, for a machine to go away, for an entire set of master and slaves to just disappear, was going to take a large effort on our part, decorating, if you will, to use the programming technology, MySQL. We were going to have to wrap it and provide a lot of functionality that MySQL didn't provide. And there's value in doing that, but that's not one of our core competencies. Right now, our core competency is getting this data in and aggregating and turning it into value for our customers. So we decided against MySQL. Mongo and HBase, for similar, although varied reasons, we also ruled those out. When we moved to the structure, it's currently only running 2 rings of Cassandra instances. One that's got the product data and one that's got all of the sentiment data, or all of the content. So ratings and reviews, questions and answers, or stories. There's a few other kind of myriad types that we're experimenting with. Those are really the core types that are driving that kind of million products or million reviews every 10 days. So we separated, we did a little bit of a premature optimization here, and I didn't feel like completely challenging my lead engineer on this, because to be honest with you, he's a hell of a lot smarter than me, and he's going to see this video. And it's true. I did mentally ask the question. He went ahead and proffered the reason that they went and separated it. And it's that ultimately clients will show up with a big XML feed and say, hey, here are my 10 million products, and go. A couple seconds later, they start going and running reports, and they expect that that's live and in the system because they dropped the XML on the FTP server. Even though it took 7 minutes to upload it, you get about 3 seconds before it should be propagated through the entire system. And it just doesn't work that fast. And so we want to be able to process those gigantic feeds as fast as possible. We want to be able to support massively parallel reads as fast as possible. To do all of that, we wanted to separate those two. They're 2 very different classes of data. We're doing a lot of computation across the product data to aggregate and find this instance of that Sharp TV at Best Buy and Walmart and at Sharp and at Costco and all of the 1,100 retailers who happen to carry that TV. And no matter what identifier or what description they give it, we're trying to find that. There's a lot of computation that goes on that product side that it doesn't really often look at the content side. The content side has a very different traffic pattern. So having those 2 separate now, it's probably going to pay off. Very smart guy. I'm trusting in him. In terms of customizations, really it all comes back to this key dead center here. The concept of, for an eventual consistency system, the concept of an idempotent operation is the concept, for those of you who haven't been in computer science programs in the last 4 years, or maybe have forgotten all of that, or maybe never studied to begin with. The concept of an idempotent operation is that I can do this again and again and again, and it has no effect the second and third and fourth times. That basically, I've already done it, and it's good, it's not going to mess things up. And so we relied on the concept that we could have idempotent operations to apply to Cassandra so that we could justify, or so that we could simplify the concept of eventual consistency. And so what we wrote was a decoration, a wrapper around Cassandra, an API, a set of APIs actually, a RESTful API, and then a JDK deliverable that other projects could use, basically a little SDK, to manage both read, modify, write operations via deltas. So basically every change that is persisted into Cassandra is done via a delta, and it manages that, and it allows us to basically specify, oh, read this and modify it, and when I go to write it, I can specify, just write it, and I'm going to trust that it's going to get there. Or I can even do a conditional write. I can say, you know what, there's a signature on the object, and I'm writing this attribute if the signature is this. If the signature is not that, then write this other thing. Or if the signature is not that, then write this other thing. And I can chain a number of attempts, or I can just say, write it and notify me if it doesn't succeed. I'm actually going to talk a little bit about kind of some of that writing process. So this conditional writes and eventual consistency. So if at time 1, I have this review come in, and it has a star rating of 5, it's a very nice TV, just got our Sharp TV again. And over here in the same data center, boom, immediately our moderation team is on it, the NLP is kicked in, this review's perfect, we can approve it, and it gets added, status is approved. Okay, great. So this is a diff, and it's attaching status as approved at time 2. Now over in a second data center, our system has processed and said, oh, hey, by the way, that reviewer who wrote that, I need to tell you that I actually found out their Facebook ID because they went over to another site that's on the Bazaarvoice platform, and they logged in there via their Facebook account. And so this way we can actually collate that information. Okay, great. So now we've written the Facebook ID, and it's this. And now we need to rectify all. Oh, okay. So we could get a merge conflict here if we're not careful, right? We've made 2 simultaneous writes from 2 different data centers. But the good news is these are just little diffs. Okay. So I can be reading T1 and T2, and I've got a fully consistent review. I can be reading T1 and T3, the different data center, and it's fully consistent, and I'm okay. And those will get merged, and over time, as long as those data centers are talking to each other, they'll reconcile that, hey, I've got T2 and I've got T3, and they came in this particular order. Write this and write this, and then collapse the thing down to that particular review. But the other thing that can happen is when we're dealing in extremely sensitive information that's changing on a rapid basis, we can use that conditional write. I don't have that example up here, but you can imagine that I'm basically going to say, only write status approved if the version is version T1. If that's the signature. The signature is basically a hash. And over here I can say, oh, you know what, T3, write the Facebook ID this as long as the signature is T1. And so what happens in this situation is those are both going to go in, and both sides can see their set of data, and they can work, and everything moves on seamlessly. But at some point in time, when those data centers start talking, I said, oh, you told me to write that Facebook ID if the signature was T1. It wasn't T1 when you tried to write that. It was T2. I can't reconcile these 2 things. It actually will notify, actually broadcasts back out on the data bus that, hey, I tried to write this. Whoever tried to write it that's interested, that write failed. You're going to need to retry. If they didn't include a bunch of retries in here, and they could. So, as I was talking to my lead engineer, he made this observation, and it really stuck with me. A lot of times with SQL, and I did this, I grew up writing applications based first and foremost on Oracle and then MySQL, and so it's really where I cut my teeth. You design your data structure to be written. You design how you want to store. You design it to be stored properly. If you took a database course in college, it's all about third normal form and all of these other pieces. And one of the things that I gave a previous database month talk about a year ago, I kind of iterated on all the ways that we've broken those rules to get the scale that we've gotten on the back of MySQL. It's a really interesting talk. But you eventually scale kind of changes your plans. You start caching results and duplicating data and just do all kinds of bad things to your databases. With NoSQL, a lot of times I'm going to design for reads. I'm going to go ahead and denormalize. I'm going to go ahead and make this data the shape and format that I want. It's going to be ready. It's going to be easy to access, and it's ready for me to use it. But when you're dealing with hundreds of millions of pieces of content that are changing constantly as new pieces of information come in, and you have tons of relationships between these that cause you to need to ripple effect that through there, this gets really computationally expensive, and you need to apply things like Hadoop to straighten that out. And so it kind of hurt that if we were going to go this path, we were going to have to do a lot of computation just to keep all this stuff in sync. Why can't we write it in a simple form and then keep kind of a denormalized form elsewhere? And now maybe you see where I was going a moment ago when I said, okay, emo is one part of this. Emo actually stores everything in a typical normalized, clean fashion. It shows the relationships. It tries not to pollute the schema with a lot of denormalization. I don't say pollute there to mean denigrate denormalization. I think denormalization is a very useful tool. But it tries to keep things clean and simple and tries to only store things once. And then, if you need a customized, denormalized copy of it, you run a copy of Polloi. And so that's actually where I want to lead in next. So with Polloi, the key attributes are we've created a declarative rules-based engine that allows us to describe the information we're interested in pulling into our Cassandra indexes. So it actually has its own vocabulary. And then it keeps a denormalized search index based on what you want. So this is actually not that far off from where we were when we were using Solr and MySQL. We're now using ElasticSearch because ElasticSearch was, again, built for the concept of the cloud. It's built in a cluster. It's built for systems to fail. It's built to elect its own master and to start and to easily start up new instances and add them to the cluster. But we've actually gone above and beyond that and said, okay, now we're going to define some very, very simple rules. Instead of having to map out your schema ahead of time and literally lay out every single attribute you care about in that schema, we'll simplify things and we'll say, write a set of rules. I'm interested in reviews that are written at best line. That's it. And all of a sudden, as those data bus events stream through on the data bus, Polloi will pull those off and write them into its index. And you can say, okay, well, I'm interested in the star rating of the review. I don't care about the text because I'm not doing a text analysis. And I'm interested in the age of the user. Okay, great. I've just built a search index in very simple terminology. I've built a very simple search index that allows me to run some very cool aggregations that say, hey, did you know that on average, 23-year-olds always rate 5 stars? But as soon as they turn 24, they write 1-star reviews? But again, like, you can do neat stuff like that, and you can do it really fast and easy. So we considered Solr, and I don't want to take anything away from Solr. Solr is a great product, and it works really well. I mean, ultimately, they're both backed by Lucene, and Lucene is an amazing technology. The thing that Solr didn't have at the time when we started this, which was a year and a half ago, is Solr didn't really have the concept of running in the cloud. They were working on Solr Cloud. It was coming. Elasticsearch was already there. And Elasticsearch was a risk. Elasticsearch is primarily developed by one developer. It's primarily managed by one developer. So there's definitely a risk involved there. But we needed something that kind of met those key goals that would give us the agility, which this was going to give us, but would simultaneously give us that fault tolerance, which was absolutely critical in the scale we're at. So the structure of Polloi is first and foremost an Elasticsearch cluster. That Elasticsearch cluster is obviously the backbone of the system. The other thing that's interesting about it is there's actually a little bit of Cassandra running inside of here. Elasticsearch has the concept of nested documents. A review, I can nest the product as part of that document. It's actually a sub-document on the review document that actually describes the pieces of the product that you might need as you're, let's say, scanning for all the reviews for this particular product. You'd want to know the product, you'd have that normalized on there. But managing those relationships in Elasticsearch was going to be a little tricky, so we need some way to definitively and fault-tolerantly store the relationships between reviews and products and categories and all of these different pieces. So the relationship is written to Cassandra, and it's used as a way to keep track of, oh, well, that product just changed. Which things need to be re-indexed? Maybe the product has been disabled and we're no longer displaying it, so we need to pull down all of those reviews. Or maybe the product name has changed, and we can represent that name change throughout all the reviews that are on it. Maybe that's a search review that we're looking for.
Elaborate just a little bit on what you mean Elasticsearch. Unfortunately, I'm thinking about it so many different ways.
So Elasticsearch is a Lucene-based technology. For those who aren't familiar, it uses Lucene library at its core, but it's basically running a search index distributed across a number of servers in a cluster. And it uses automatic discovery to add nodes and remove nodes from that cluster. And it's running a search index. It's actually running an HTTP API. You can query directly from it in various in a Lucene-based query format. And you can search documents and return those documents, serve those documents out.
So if you're running an index, is it dynamically changing the index every second?
So it does, like as Scott alluded to a moment ago, it does support much more rapid updates to the index without some of the performance that Solr had. And so what we do is so typically those are batched. So it's monitoring the data bus. It's seeing those events come through, and then typically you don't want to try and write every second. Typically you batch them into 15 seconds, 30 seconds, depending upon your performance needs. You can tune how quickly and how often that's being written and optimized too. Sure. Did you have a question about?
Yes. So you mentioned that you're using Cassandra for relationship with data, right? Joins and relationships are not what Cassandra was designed for. So how you do it? Did you implement your custom relationships column families, or how it's done?
Yeah. I'll have a little bit of a hard time speaking to the intricate details. I'm going to repeat the question just so that those who maybe couldn't hear it. So his question was, Cassandra doesn't really support a lot of relationships or any sort of joins. No, you're absolutely right. It's definitely sets or kind of, in our parlance, they're tables, because we like to bring the MySQL forward and still have tables inside Cassandra. But so there are tables of data, and each of the items in there has an ID, and so we're able to say this thing is its parent is this, its product is this by its ID, and so no, it's definitely not optimized. But the thing that we got by using Cassandra was that fault tolerance, that ability to have it distributed across a number of systems and not worry about it failing. So it's become our hammer with the fact that, hey, we have to deal with that things may fail. So Cassandra has been a tool that we use a lot in that space. It may or may not be optimized for that, but it certainly has worked well for us. And the other thing is these three pieces inside here are all fairly loosely coupled to each other and to the external world, so that if we can find a better solution for it, that's certainly an option for us. But we need it in some way outside of Elasticsearch, whatever it may be, to store those relationships so that we could take care of re-indexing rules and make them efficient and not have to go back to some other system to kind of keep tabs on that.
We built basically a lightweight graph traversal sort of semantic layer on top of it. So we have a lot of problems that look just like graphs, right? So like some of our customers, somebody like P&G, right, may have a couple hundred brands, and we need to understand that, this brand belongs under, is a child of the P&G brand, right? Or, this product in this catalog is, belongs to the, the consumer electronics category, but it also might belong to the temporarily on sale category and those types of things. So we saw a whole bunch of problems that looked kind of like this, and we built basically a very lightweight graph traversal API on top of Cassandra just to be able to reflect those kinds of relationships and allow us to traverse the graph quickly.
Okay, understand. There's actually a solution that does something like that called Titan DB. It's a graph that also fits on top of Cassandra.
Yeah, I think we've actually done. I think we've done a little bit of research into that. I think I remember hearing that. I think when we started this, that was either less well known or not quite as.
It was version 0.1 some time ago, so it's not mature yet.
Yeah.
But it's going there.
We like to wait till at least version 0.2 before we put it in the display path for 1 billion impressions a day.
Totally not true.
So another question I had is that you mentioned that you're using conditional updates. You're doing conditional updates in Cassandra, right? Since Cassandra gossip protocol between the nodes is only using timestamps when it determines what version should be propagated around the cluster, how did you implement this conditional update?
So the conditional updates are based on those signatures I mentioned. And so we don't guarantee, obviously we can't guarantee perfect consistency across every data center simultaneously. That's just not going to happen. And so what we gave ourselves was strong consistency within the data center and less strong light consistency. There's the term consistency in a moment. Weak consistency, which we gave.
Like local quorum.
That's right.
Yeah. So I'm going to get into it in just a second. So I want to jump back to the slides. So the last and very interesting piece of this is this rules engine. So this rules engine allows you to declaratively describe both the data you're interested in, the rules for how you would like it written. And there's some really interesting pieces that we built here that I think really deserve some attention. In terms of the customizations, I'm going to go into in a moment. The customizations we made, we're using the AWS Cloud plugin for Elasticsearch. Since we're running in AWS and it does discovery within its cluster, it normally does that via network broadcast. That's not going to happen. It's not that. And so there's a very simple plugin you can run that allows you to do that. Additionally, we built a custom plugin that gives us three pieces. It gives us discoverability. It plugs it into kind of our SOA index in Zookeeper so that it's kind of completely available, but also we can know which systems are up and which systems are down. And it gives us monitoring. So it gives us monitoring. It's an internal system. It's not being run on the external web, so we can't use Pingdom or any other service to check it's up. We can't check on it with Datadog. So we've built our own conduit for that information, something we refer to as Badger. And basically, it has an API that it registers back with Badger, such that we can then monitor these and be notified if the system goes down, if we lose an individual one, if it goes over the threshold, we lost 2 out of the 6 nodes in the cluster. We can manage all that. So.
For what it's worth, we have actually open sourced our discoverability and SOA frameworks in GitHub. It's a project called Ostrich.
Yeah, that's a good point. Yeah. So there are 2 really interesting times when you're running a search index at this scale. The first is the initial load. That's a very interesting time. The second, and slightly less interesting, but still very interesting, is this concept of keeping up. So starting with the initial load, to get 100 million plus reviews into your search index, you need some way to do it fast. Since Polloi was built to read from the data bus, to read these diffs, these objects as they stream across the data bus, to know various events that have happened in the system, it was built to handle the fact that things were going to come out of order. It was built to be aware of that and be okay with that, and to deal with the eventual consistency that Cassandra was presenting to us. So we got to take advantage of that. This is a really cool trick. It wouldn't have occurred to me, but it occurred to my guys. And in the sense that they said, hey, if these things can come out of order, if they can come relatively, within a day's time frame out of order, okay, let's chop up, let's slice or segment the data. Everybody's going to pull their own little piece of it and then index. And we're going to build a whole bunch of indexers out. They're each one going to pull a whole bunch of information. They're going to index it in at a rapid rate. And by the way, hey, Emo, we're going to do this. You're not going to like it because we're going to read from you at a really massive rate, because we might turn up 10 or 100 of these indexers and just absolutely just take a dump truck load of data out of Emo and put it into Polloi. So maybe you want to take that into account. And so Emo actually went ahead and as part of its API, provided this concept of asking for slices, which are basically sequential sections of data that are basically streamed directly off of the disk and up into Polloi. And so it can do a re-index very, very quickly. As I'll talk about in a future slide, there's still some gaps here. Can't wait to see what we can do when we actually turn loose 100 indexers and just want to snap that data back into shape in an hour, or I don't even know how fast. We haven't gotten to turn it up that high yet. The other piece, and this is the piece I can't really talk about in the presentation just for lack of time, is this automatic rebuild and then launch. We built a set of CloudFormation scripts that decorated kind of Polloi and that entire concept of Polloi cluster, the ElasticSearch, Cassandra, and the rules engine pieces, and launched that, set off the reindex, and since it's moving into that, it's in that SOA framework, it goes ahead and it registers itself. It registers itself as dark because the index is not yet complete. And it's doing this massive reindex for all these different slices. And when all those slices have been re-indexed, it goes ahead and it marks itself as light and disables the other index and seamlessly replaces itself in your system. And so you've got this push button way, either API or UI, to load a set of rules up and have it pull all of your data and then just seamlessly upgrade when you're done. The other interesting time is keeping up. If you miss even one event, it becomes very, very hard to reconcile the rest of the events going forward on that object. And so missing one event is very, very dangerous. So that's why we ended up building the data buses. We needed some multi-data center way to know that, hey, this message was there, you were subscribed to it, you disappeared, there was a partition between that data center and this data center, we're going to wait for you to come back. And obviously there are gaps here. If you're gone for too long, systems are assumed to be dead basically after 24 hours. And so if systems that were down for 23 hours and 59 minutes and then comes back, it's okay. But at the minute you go to 24 hours, our system is aware that, hey, you've been gone for 24 hours. We don't know what state you're in. We've probably collapsed a lot of data behind the scenes on you. You need to start fresh. So it's using those objects coming off the data bus. It updates the objects as the changes come in, and it manages those relationships. Actually, we talked a fair amount about that already. So the rules engine is a really interesting piece. And I put this slide. This is really more for me than it is for you. This is an XKCD comic. If everybody saw it, this is the one where you could just kind of Google Earth around. It's just huge. But I didn't expect this to be the big deal. This was a really interesting part of what we did. So we built this rules engine and vocabulary. The rules engine allows us to normalize and effectively join data. So we're describing it in a declarative way. I want this table or this set of reviews data, but I want to include the product data, and I also want to include the full set of category data. I do it in a very declarative, very straightforward text file format to describe this. And as the data is streamed, as the data is loaded out of Emo, it does those denormalizations for me. It does a pre-computation. I can say things like, I want to know the average of this field across all of the sub-objects. So as I join as I'm indexing products, I can say, I want to know the average star rating across all the reviews that have that same product. And it maintains those relationship consistencies. So it stores the fact that, hey, this review is related to that product, and as those things change, it will be indexed for me. We also built on this book. Yeah, sure. Right, so the question is,
how do you address that?
yep. So the question is, can the formats change based on per customer? Yeah. So the answer is yes. Within a limited scope of things, there is flexibility between one customer and the next. So some customers are going to take tagging and use tags on their reviews. Some are going to take all these context data values, like how old are you, or how many days per week you use the skill saw. There's all sorts of things that you can do, but there's a limited set of those. And so in effect, some of which are dynamic, but effectively, those are fairly well defined, and so they're defined as part of the rules, and especially as part of the vocabulary.
How far do you go with this? I feel like that given the scale of problems that you're running with the rules, it's not surprising sometimes people have a certain behavior from the client. They won't tell you that they're changing something, and then you discover that through some kind of truth-making mechanism, preferably because you want to make that versus active discovery, which we call compliance.
Sure. So to your point, you may not know all of these changes are coming in. Thankfully for us, all of the changes of that nature are typically made through our configuration system. So we can get notified that, oh, they're adding a new context data value. We can begin to capture those from the get-go. I definitely would like to talk a little bit more about that offline. It's an interesting conversation. So in the vocabulary piece, we defined this vocabulary that allows you to say, you know what, a person has a name, as does a product, and as does a category. As a matter of fact, when I talk about a name, this is what I mean. I mean its name. And so it simplifies the schema description. I can say name means this, it's a string, and then from then on, when I start indexing these things, I can just refer to it by its name. But it also allows us to kind of dynamically, from the set of rules, compute what the schema for your search index needs to be. Compute the set of fields that we're going to need to store. You've told me the fields you're interested in, both in terms of which ones you want indexed, but now also thus the ones you want to query by. It allows us to filter the data so we can keep the index at the right size. Additionally, it allows us to optimize. So it optimizes the triggering. So as new things are coming in, we can optimize how much we're re-indexing, and we can optimize how much we're having to scan. We can actually do interesting checks of like, hey, this has changed, but I can see further up the line it's going to change back. I can just leave it. So it hasn't been all roses. It's actually been rather difficult. It's been a pretty long road. There are some really interesting things. So one of the things that I mentioned that I said I would get back to is this concept of how do you deal with compaction? How do you deal with dealing with differences between multiple different data centers? So what we've done, and it's using a number of features that are built into Cassandra, is we've set a threshold that says if data centers are detached, or if a system is detached from its cluster for more than one day, heaven help us if this ever happens at the data center level. I don't know if you're aware of that. If the system is gone for more than a day from the cluster, we're going to write it out from the cluster and we're going to rebuild it from scratch. Because every 24 hours we run the MySQL compaction, the Cassandra compaction, to take all of the set of differences and compact them down. So that instead of having a whole lot of just chaining differences in that database growing and growing and growing, we can simplify down. I equate it to the similar process that we typically run inside of BI cubes. That basically, instead of thinking about, I want to know every single detail, at times I'm going to want to know it in aggregate, and I'm not going to need to know all the details anymore. I've got a bit of an audit history, but I don't have to know every single detail. But it's definitely a gap. It's not one we've run into yet, and it's definitely a configurable setting that we're going to have to mess with. Staying on the Cassandra side, my team here in New York constructed a bad write. With an eventual consistency system, you retry your write until you get a confirmation that it's going to be there. And so we were writing these responses written by a client, and we wrote something on the order of 1,300 responses, but it turned out to be a little bit over a gigabyte of data when it was all said and done. And that's all fine and dandy, except there was a subtle difference between each of the writes that we were making, and Emo decided to store all of them. So all of a sudden, this one review was now loaded with about a gig, a little over a gig of response data. And So then we subsequently said, hey, tell me about that review, and it tried to load that gig of response data. And at the time, it didn't try to stream it, it just tried to pull it all into memory, and then we kept calling, and it kept loading into memory, and we ran that system out of memory. And we don't yet have circuit breakers in place, and so we moved on to the next server in the cluster, and we ran it out of memory, and we moved on to the next server. And yeah. So we learned a lot of good lessons. We learned we need to get circuit breakers in place, obviously, if the query is bringing down a system. And once you can begin to identify the pattern, you stop asking the query, or you stop responding to the query. But we also learned that this retry logic of writing is going to be a dangerous area. We're going to have to watch it carefully to prevent people from creating these set of bad reads. We've actually since fixed the out-of-memory exception such that it's slow. It's going to be slow. You're loading a gig of memory, or you're loading a gig of stuff from disk into memory, so it's going to be slow. With Elasticsearch, we've had a little bit of trouble in AWS with master election. Since you don't denote a given master for Elasticsearch, it chooses its master by talking amongst the various instances. There are times, and we heavily suspect actually garbage collection, yet again, to be involved in this, that there are times when it will partition itself because one system gets a little too busy. They can't talk to each other because they're busy running away in garbage collections. They can't even take care of the networking issues they need to. And so then a partition develops between them. They elect two new masters, and then the partition evaporates, and they try and go back together. And having two masters is still something that is still a little wonky for the system to come back from. So I think we've got our hands around this. Worst case scenario, there's actually a really easy fix for this, which is to use Zookeeper for master election. We try to keep the complexity on all of these projects as light as possible, both to keep the agility high and to keep the fault tolerance high. And then the last piece was managing the set of indexes. When you've got that amount of data, you're not cramming it all in one index. So we thought, okay, great, we'll partition by client, no big deal. Each client gets its own index, and we just go. Now we're running 2,600 indexes, and we're running various multiples of that because of other different content types. And all of a sudden, we're running a whole bunch of indexes, and we ran out the open file names on the system.
For Cassandra operations, did you write any internal tools or use like a data stack stuff or like Prime?
Yeah, we use Prime. We've actually, I think we started contributing on Prime for a while. We've been communicating with NetBus pretty well. They're aware of what we're doing. And actually, like, Adrian is actually coming down to speak to our internal conference next week. Which is really exciting.
So we did some simple things on Elasticsearch to just be a little bit smarter about how we decide when to create an index and basically have data kind of sharded across indexes, but also an individual index might be composed of various different types of data mixed together and have that be safe. So interesting stuff. Not been the easiest thing in the world, but it's been a really fun challenge. And with that, if there are any more questions, I know we've answered a few questions, but I'm happy and Scott's happy to answer if you want. Yeah, sure.
So how many servers do you have for rings?
Oh, I apologize. I was supposed to.
That's all right. I was you can take that question since you asked it already.
So your question was how many servers?
Yeah.
Offhand, it's in the teams right now of Cassandra instances, Cassandra rings. So each one of those is still pretty small. So each of those is running, I guess just three. I think it's just 3 nodes in the ring right now. So it ultimately nets out to probably around 20 or so for emo. And then for Polloi, each Polloi cluster, if you will, is about 10 machines. We're running 4 different search indexes like that in production. But then you've got the staging and dev instances. And I said I would mention this, and I think I got distracted and forgot. That master election piece that I was talking about there, that's a bug we're still working on, and it occurs as soon as you get more than 3 indexers in your little cluster. And so that's why we haven't been able to crank it up to 100 for temporary stints. But typically, we try to structure things such that we kind of maintain a level of machines that's kind of the baseline with some additional overhead, and then have systems scale up and scale back down because the amount of traffic we serve, at 8 p.m. at night is very, very different. US is very, very different than the traffic we serve at, say, 3 p.m.
So how much data you were serving the service using
You can hold that question 1 second. Before we move on with Q&A,
first I just want to give a great big round of applause. R.C. Johnson is stopping in. After the end of the Q&A, we do have an entire box of swag sitting here to give away. It's just forever comes up and takes it at the end, so hang in there. I'm sorry, your question was what? I didn't.
What's the volume of the data you would serve?
In production, the emo instance is just shy of, or just tapped over a terabyte of data. And we still don't actually have all the data indexed into there. This is still very much a work in progress to get this content into here. Yes.
I have 2 questions. The first one is, how is mobile changing your product? And the second one is, when you have big brands like P&G, how are they taking and handling your data, especially in this new big data environment?
Sure. So the question was basically, the first one was, how is mobile changing what we do? And then for somebody like P&G who has a bunch of different data across a bunch of different brands, sort of how do they interact with us? So to the first question, mobile has impacted us actually fairly substantially. So as I talked about before, our display side application, which is integrated directly into the site, used to be based on this kind of relatively heavyweight server-side templating. Part of what we've done in the move to our new infrastructure there that's based on things like Node and Backbone is we have taken really kind of a mobile-first approach. We've built everything with responsive design in mind. So if you look at the customers that are deployed on our new application stack, you take that browser window for, I think Travelocity is one of our major new clients that's by traffic, one of our top 20 clients by traffic that's using it. And if you go there and grab that site and sort of on your laptop and just take the window, scroll it down, you'll see the review content will start shifting around. It'll lay itself out nicely to fit the form factor. Pull it up on a tablet or on a mobile, and you'll see those types of things baked in. So we built that in sort of right from the core. In terms of display, how it's impacted things on the server side is we've made an intentional decision to basically go fully services-oriented architecture with a RESTful API and have HTTP basically the protocol that everything talks basically internally. So originally, when we built the first version of the system, it was just a closed-off, monolithic Java system. And we eventually put an API on top, but the API was kind of bolted onto the side. We've inverted that relationship now to where even the core application itself talks through a set of APIs. And those APIs themselves are available for anyone else to use. We've turned around and created open source versions of SDKs for those APIs in iOS, in Android, and for Windows Phone. And customers like OpenTable, who get a lot of their traffic on mobile, will utilize our mobile SDKs and our APIs to actually go build into their own native applications on a platform-by-platform basis. They can consume that content in the way that most makes sense to them.
But vernacular and content too with mobile, right?
Sure. So the question was vernacular and content are changing too. Absolutely right. So someone is not going to sit down and say write a long form review that might be 1,000 words long on their mobile device, right? So one of the things that we're also trying to go do is increase the set of ways that we can capture information. So taking OpenTable is an example again, right? We can know, it's possible for us to know because OpenTable knows that you made a reservation at a certain restaurant at 8 o'clock at night. By 9:30, you've probably received your bill. We could hit you up and say, hey, did you have a good experience? And and sort of tap and swipe, say, hey, yeah, thumbs up, thumbs down, and start to capture content, sort of much more, more quickly that way. Everybody's taking pictures of the food these days. Wouldn't it be great if we could plug into Instagram and say, hey, the queso at this place was fantastic, and it's geotagged and said, oh, I was at this restaurant. Oh, by the way, those types of things. So our product management team and some of our discovery engineering teams are hard at work on some of those things right now. One concrete example of this that you can see right now is we've done a pilot with Patagonia, actually, which is basically social shopping. So instead of having sort of a categories or left nav, kind of based approach, it actually takes a very sort of visual tile-based kind of approach, and it's entirely driven by sentiment. So it's a page composed of pictures and videos and ratings, and and you navigate basically in that context. Works on tablet, works on desktop, works on your phone. This one was really cool, I thought, because I saw an email said, hey, we launched this, and I went to go click on the link just to see what we had done. And then like 10 minutes later, I realized I was shopping. I went, it happened totally by accident, and it was really cool. So to answer your question, it's impacting us in a pretty significant way. What we're doing from a technology basis is putting ourselves in a situation to be able to go capitalize on whatever opportunities present themselves as quickly as we can. And sorry, the second part of the question as it pertains to P&G. There is no one very simple answer to that question. We have a couple of customers like P&G that are huge, that have dozens, if not hundreds of brands across many different market segments. And what we are really basically doing is, from the infrastructure standpoint, putting ourselves in a situation where we could say, okay, look, I'm the brand manager for health and beauty products in North America for P&G. I want to go be able to go interact with the analytics on the system for those brands and those consumers that are under my purview, slice and dice the world that way. Or you might be the person that's responsible for a particular product globally. Now, you don't care so much about geographic distribution, but you do care about how that product, that one product exists, across the world. So what we're trying to go do, part of that is in modeling these relationships. Part of it is in having, multi-data center and sort of multi-master kind of basis, is to create the ability for when those types of opportunities, sort of come up, we can go in there and say, okay, here's a slice of the product that's designed to be able to go solve that particular problem for big houses of brands like P&G. But it's an evolving thing.
Integrating with the data warehouse.
Hang on, let's just move on. We'll come back if there's time. I'm sorry. Just for the reference, they will be here after the end of the Q&A for one-on-one questions. So, next question. Yeah.
You mentioned at the beginning of your talk that database solutions are there's not a one-size-fits-all. You start with MySQL and you move to Cassandra, but are you finding that there are still some legacy applications or something within your organization, your stack, that still MySQL is still good for?
Of course.
Well, I mean, you definitely sold it Cassandra trade. So what is that for your case?
Yeah. So the most obvious case for that is simple reporting. Right, so the stuff that where you do have to do a bunch of joins, where there really is a case for relational data, but it has to be one where I can put a bound around it and say, look, this is never going to get bigger than a certain size. Like part of the reason that we've moved to Cassandra is because it doesn't have the same kind of vertical scaling challenge as something like MySQL, or horizontal scaling challenge as something like MySQL does. So as RC alluded to with respect to Cassandra, it really only has 3 jobs, right? One is it needs to be able to do efficient read and write by key of effectively a schemaless or kind of a document object. It needs to be able to scale horizontally so that when open table adds its 30 million for view and 40 million for view, I'm not like freaking out because they're on a single MySQL instance and it's going to take everything down. And then it needs to be able to support these bulk read operations for the purposes of bootstrapping these Polloi indices. But we do actually, as it sits right now, currently index out of emo from Cassandra via the data bus into MySQL for the purposes of some horizontal reporting technologies. And the idea is we don't want to make any judgment or prejudgment about what a particular search index for a particular thing is going to be able to go do, or is going to need rather. So if MySQL makes sense, or Vertica makes sense, or Elasticsearch makes sense, the database doesn't care, right? Polloi happens to be one thing that if your usage pattern looks like this, it's very formidable. But relational databases are not going away; they still add a lot of value, particularly these cases.
Yeah, here in New York, we've used them extensively. We use MySQL extensively as a bootstrap. And the guys that I hired onto the team were very familiar with MySQL, still not as familiar with Cassandra, but they're getting there. And so anytime we're starting up a new project, we're building something new kind of from scratch, we go back to the things we know really well. And so MySQL is really simple to run in kind of small fashion and just start up with Amazon, just fire up an RDS instance and start firing stuff into it. Yes, we've dealt with some like, we've got to do a schema migration, and how are we going to deal with that? And the system still be awake, and all those pieces that I've seen 100 times before. But the application has 5 users, and so we just go, look, they're all off, quick, do it, and move on. So it still very much has a use case for us.
Okay, we have time just for one more question, all the way in the back.
So this remote resistance that we just discussed when you have daunting, Cassandra, Elastic Index, and Vertica Analytics, MySQL, how this remote resistance is implemented? Is it on the services level? When the service gets data, it writes it to different storages, or it's like asynchronous triggers? How do you do it?
Yeah, so the system of record is, which is emo, the Cassandra basis, is the single source of truth. right? Everything else is expected to be downstream of that, and we've designed everything so that if we do wind up in one of these situations where we have an inconsistent index, it's relatively straightforward to go off and rebuild. We have the benefit in many cases of not needing to have, not generally speaking, needing to have real-time access to something immediately after it's been written. So one of the things that was alluded to, but we didn't talk specifically about in the talk tonight is we actually have a team of people who actually go do moderation on the content. We also have some machine learning and natural language processing that does it as well. But some of our customers, for instance, live in highly regulated industries like financial services or healthcare, et cetera, and there are like requirements in there that we have to make sure, like, you can't mention an off-label use of a medication. Example, you couldn't go review Advil and say, I don't take it because it cures my headaches, I take it because it clears up my skin. You can't do that. Like, the FDA won't let you do that. So, but the benefit of this is people don't expect broadly for, not like say Facebook or Twitter where you post something and then you refresh the page and it's immediately right there. We have a little bit of lag inherent in the domain that we're existing in. So if it takes a few seconds for that write to go from Cassandra out to the content moderation system to get auto-approved by an NLP engine that gets indexed into ElasticSearch, if it shows up 15 seconds later, nobody really cares. In fact, we've lowered that SLA from like 72 hours down to like a few seconds. So we've improved that really for the last year or so.
And just to give a little more context, so from our perspective, there are times when you need that. You need that immediate flexibility. Since we are the ones who are running that Polloi instance, we can write to it as well. And so the trick that my team has used when the response is posted, the client is expecting to see it, at least in the tool, and the tool is exclusively reading from ElasticSearch, from Polloi. And so we just write to Polloi directly, just say, hey, by the way, there's a response on this. By the way, this has no ID yet. When you see it from the data bus, make sure and update it and replace. Anything you found here, don't trust it. It's kind of basically marked as dirty, and wait for the copy to replicate through from the system of record data bus.
Okay. Scott and RC will be here for one-on-one questions afterwards, and I'm about to dump out all this swag for you guys, so hang in there. A great big round of applause, Scott, Bonneau, and RC.